Hello all, let's start the second part of 7.4, which is case 3. Still we are dealing with the rational functions, their integrals. In case 3, I put some notes here for you. Q of x contains irreducible quadratic factors, none of which is repeated. If Q of x has the factor of ax squared plus bx plus c, where b squared minus 4ac, which is your determinant, you know this from algebra, is less than 0, then in addition to the partial fractions of case 1 and 2, the expression for Rx over Q of x will have a term of ax plus b over ax squared plus bx plus c. What does it mean? Let's translate this right into, and let me explain to you an example. For example, if I have integral of 2x plus 5 over, let's say, x times x squared plus 3. Correct? Here, your denominator has a quadratic factor. One of the factors of the denominator is quadratic. And this factor, if you look for determinant for this factor, it's less than 0. b squared minus 4ac is less than 0. It means when b squared minus 4ac, hopefully your professor in algebra class explained to you, when your b squared minus 4ac, which we call a determinant, when this one is less than 0, it means you cannot factor anymore. It means if you factor, your answer will be imaginary number. It means we cannot factor, right? Here, x squared plus 3, we cannot factor it anymore. You have one irreducible or maybe more irreducible quadratic factor. In this case, how to set the integral, or how to, before the integral, how to change this fraction to its partial fractions. What you do, I'll show it here. You have 2x plus 5 over, for example, x times x squared plus 3. How you deal with this, you set 2, you know, y2, because your power is here 1, your power is here 1, 1 plus 1, 2. It means you need 2 fractions on the right side. You set 2 fractions, you put your linear factor here. When we have linear factor, we put here a. When you have quadratic factor, which you put in the second denominator, x squared plus 3, here the top will be ax plus b. You used already a, you can write the top as a bx plus c. Or let me tell you in an easy language. When the denominator, whatever the exponent of denominator is, 1 less than that will be the top. If you have here x cubed, you have to set the top as a bx squared plus cx plus d. That means 1 less. That's what they explain here, and that's what that note means to you, correct? The rest, how to proceed, it will be the same method that you did in case 1 and case 2. You have to make the denominators the same, you multiply the top, and after that you set all the numerators equal to each other, and you create a system of linear equation, and after that you can deal with integral. One more note, this term, which is bx plus c over ax squared plus bx plus c, can be integrated by completing a square. By completing a square, or if necessary, I'll put F for you, most of the time you don't need to. In some problems, you have to do first completing a square or if needed. Let me add needed also for you. If needed. And using formula, I will put the formula integral of, you know this integral, we did it in chapter 6 or maybe calc 1, that integral of 1 over x squared plus a squared dx equals to 1 over a inverse tan of x over a plus c. You will end up with a factor like this, with a fraction like this. And whenever you end up with such a fraction, you replace it with 1 over a inverse tan of x over a plus c. Now, I'll do a numeric example. Let's do an example and let's apply the rule. One example will be enough for you. And let me tell you something, that this week I was a little bit slow with chapter 7. I didn't put all chapter 7s together because chapter 7, you're learning all techniques of integration. Even in these problems and some parts, you will see that maybe you need substitution. Maybe you need integral by part. Those cases, you have to be really good in it. By looking to the problem, you should know which part, which rule you should use. Anyway, let's do this example. You will see how they're coming back to you, 7.1, 7.2, 7.3. They're coming back in these problems, correct? Example number 1, evaluate. Integral of 2x squared minus x plus 4 all over x cubed plus 4x and dx. The first thing to do, like case 1 and case 2, you have to factor the denominator. You can rewrite this one as an integral of 2x squared minus x plus 4 over, here you can factor x, and the remaining will be x squared plus 4. You see, you cannot factor anymore, right? Of course, dx here. You cannot factor the denominator. Now, I will deal and I'll change this rational function to its partial fractions, or in other language, I will decompose this fraction, right? 2x squared minus x plus 4 over x times x squared plus 4. I need definitely two fractions on the right side. The denominators will be x and x squared plus 4. Here I have a linear factor. I'll name the numerator a. Here I have a irreducible quadratic factor. The numerator will be bx. Because you have bx, you need another constant of c. From here on, you should be able to do it by yourself, but still I'll complete this example. Now you have to make the denominators the same, right? To do that, you have to multiply the top and bottom of your first fraction by x squared plus 4. Here, x squared plus 4. And the top and bottom of second fraction with x. Now, denominators are the same. I will remove the denominator and I'll just deal with the numerators. I'll make an equation for me here. 2x squared minus x plus 4 equals a times x squared plus 4 plus x times bx plus c. Distribute a here to both terms, and here distribute x to both terms. Then 2x squared minus x plus 4 equals ax squared plus 4a plus bx squared plus cx. If you remember from case 1 and case 2, the terms that they have a square, I'll bring them together. Actually, I'll kind of organize the right side, correct? 2x squared minus x plus 4 equals ax squared plus bx squared. And after that, I'll put cx. I will order and plus 4a. The next step was if you can factor x squared, factor, correct? Then 2x squared minus x plus 4 equals, if I factor x squared, I'll end up with a plus b, and x squared is common in both, plus cx plus 4a. Now you compare the right side with the left side. A plus b, you can write an equation. A plus b, your first equation, equals the coefficient of x squared on the right side equals to the coefficient of the x squared on the left side. That means a plus b equal to. Second equation, the coefficient of x equals the coefficient of x on the left side. That means you can write c equals -1. And the coefficient of the constant, or the constant term, even, I'm sorry, no coefficient, the constant term on the right side, you can make it equal to the constant term on the left side. That means you can write 4a equals 4. A very easy system of linear equation. This one is really easy. You have the value of c already, and here if you divide both sides by 4, you can get the value of a. You see, if I divide both sides by 4, 4 cancels out with 4, then a is equal 1. And if I plug the value of a in this equation, here, 1 plus b equals 2. It means b equals 2 minus 1. That means b equals 1. Now, I have the value of a, I have the value of b, and I have the value of c. If you see at the beginning, let me make it smaller, let me zoom a little bit. Your first equation here, when you make this equation, you have 2x squared minus x plus 4 over x times x squared plus 4 equals to a times, you see, let me bring it here to show it for you. You have a times x squared plus 4, or sorry, even the first one. The first numerator was a, you had a over this one. Just the black letter. You have a over x plus bx plus c over x squared plus 4. Now you have the value of a, b, c. Just plug in here. Those will be your partial fraction. That means this one will be, how much is a? Your a is 1. It will be 1 over x plus b. How much is b? Your b is 1. 1x or x plus c. How much is c? -1. That means x minus 1 over what? X squared plus 4. Now, next step, we will deal and we will take the integral of this, which is equal to that one. Then I can write the integral of 2x squared minus x plus 4 over x cubed plus 4x dx actually equals to integral of 1 over x plus x minus 1 over x squared plus 4 dx. Now here you have the addition of two integrals. You can write as a separate terms. The first one is easy. All of us at this time, at this chapter, we know what is the integral of 1 over x. It's really the easy one. The integral of 1 over x is ln x, ln absolute value of x, right? This part, do we know how to deal with this? Your denominator, you cannot factor. When you cannot factor, you can write as a separate integrals. Let me show it for you. You can rewrite this one as an integral of 1 over x dx plus integral of x minus 1 over x squared plus 4 dx. Now, this part, I told you, it's easy. Integral of 1 over x dx gives you ln absolute value of x. Plus, how to deal in this part? Can I rewrite x minus 1 over x squared plus 4 as a two separate fractions? Definitely. I can write as an integral of x over x squared plus 4 plus minus, actually here you have negative, before I forget dx, minus integral of 1 over x squared plus 4 dx. Now you see, I told you that sometimes you need your chapter 7 to deal with some integrals. Look at your second integral here. Here, you see, I will use the substitution method. Why I'm so fast in it? Because when I look at my denominator, when I look the numerator, I see the derivative of denominator in the top. The derivative of x squared is x. Then definitely here I'll use substitution. For this part, which is 1 over x squared plus 4, I will use the formula that I put the note for you. 1 over x squared plus a squared. Definitely, I'll use a trigonometric integration here. Let's deal with. Then ln x, then ln absolute value of x plus. For the second part, u equals x squared plus 4. I'll use substitution. Then du equals to x dx. And 1/2 of du, if you solve it for x dx, 1/2 du equals x dx. I have all parts of my substitution. Then I'll use here the substitution plus integral of 1 over u instead of dx. Instead of dx, you are adding 1/2 of du. 1/2 of du plus integral of 1 over x squared plus 4 based on the formula that I put for you. You can easily find this integral. This integral will be 1 over a. Your a is how much? 4, right? Your a is 4. That means 1 over 2. Inverse tan of x over inverse tan of x over a. If a squared is 4, then a will be 2. X over 2 plus what? Plus c. The sign is negative, not positive. Here you have a negative because of this negative sign. Now let's simplify this one, this part now. Then ln absolute value of x plus, you can put 1/2 in the front, 1/2 integral of 1 over u du minus 1/2 tan inverse of x over 2 plus c. Now, what is integral of 1 over u? The integral of 1 over u definitely will be absolute value of u, ln absolute value of u, then ln absolute value of x plus 1/2 ln absolute value of u minus 1/2 tan inverse of x over 2 plus c. Now, how much is u? Substitute back your u as x squared plus 4, and you can write ln absolute value of x plus 1/2 ln absolute value of x squared plus 4 minus 1/2 inverse tan of x over 2 plus c. Final answer. The only new part in case 3 was if you have a quadratic, irreducible quadratic factor in the denominator. The rest was all review of 7.1 to 7.4. When I did substitution, you learned substitution in chapter 6. When I did the trigonometric substitution, even you did it in Calc 1, and also we covered the trigonometric substitution and the trigonometric integration in chapter 6. This was your case number 3, correct? Last case of 7.4, case 4. In case 4, Q of x contains a repeated quadratic, irreducible quadratic factor. Like in case 2, you had repeated linear factor. Here you have repeated irreducible quadratic factor. It means in this case, you have to use a1x plus b1 over ax squared plus bx plus c plus here a2x plus b2 over ax squared plus bx plus c to the power of maybe 2 plus dot 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 ar x plus br over ax squared plus bx plus c to the power of what? Definitely r. It's a general form, right? If you have only a square, it means you use this part. If this power is 3, it means you have 3 denominators, correct? But basically, it's the same as case 2. The only difference is that your denominator is a reducible quadratic factor. Let's do an example. This example is a little bit longer, but most of the part I will just write the answer for you, because at this time I'm thinking that you are good in chapter 6 and chapter 7. I give you enough time to learn those, correct? Okay, evaluate again. Integral of 1 minus x plus 2x squared minus x cubed over x times x squared plus 1 to the power of 2 dx. Here you see your denominator has a repeated quadratic, irreducible quadratic factor, correct? If I have x squared plus 1 squared, it means the right side, one of the denominators will be x squared plus 1, the other one will be x squared plus 1 squared, and the other one will be x, correct? Let's set up our fraction. First of all, let's order the top. The top is not in a nice order. Let's order it in descending order. You can write negative x cubed plus 2x squared minus x plus 1 all over x times x squared plus 1 all squared. This one equals 2. How many fractions I need to the right? 2 plus 1 gives you 3. It means I need 3 fractions on the right side. Here you go, your 3 fractions. What are the denominators? The first one is x, the second one will be x squared plus 1, and the third one will be x squared plus 1 all squared. These are your denominators. Now, the top, this one becomes a, this one becomes bx plus c, this one becomes dx plus e. I used all the alphabet here, right? Correct? Now, next step is the same. You have to make all denominators the same, right? To make the denominators the same, here, if you compare the first denominator with this denominator, x squared plus 1 all squared is missing. You can multiply this one by x squared plus 1 squared. If you compare the second denominator with the left side, you can easily see that you are missing a factor of x squared plus 1 and also an x. That means you will multiply the top with x squared plus 1 and another x. And if you compare the third denominator with the left side, you see you are missing only x here. And you multiply top and bottom with x. Let's rewrite just our numerator, and after that, let's distribute and do some algebra, right? I'm not doing, at this part, no calculus. Even I'm not using calculus right now. What I'm doing, I'm repeating college algebra again for you, correct? Then you can write negative x cubed plus 2x squared minus x plus 1 equals a times x squared plus 1 all squared plus, even I can put the x here, it's much better, x times bx plus c times x squared plus 1 plus x times dx plus e. In the first part, you cannot distribute a because you have a power of 2. First, you have to FOIL this. Then you can write negative x cubed plus 2x squared minus x plus 1 equals a times. Here, you can use a plus b all square formula, or you can multiply x squared plus 1 with x squared plus 1 and write the result here. I'm using my formula, a plus b all square. The square of the first, x to the power of 4, plus 2 times this term and this term, which gives you 2x squared, plus the square of the third term, which is 1. Here, you multiply 3 parentheses. The best way is to first distribute x, then the result multiply with this. X times bx gives you bx squared. And x times c gives you cx. That means bx squared plus cx times x squared plus 1. Here, distribute the x. X times dx gives you dx squared plus x times e gives you ex. Now, here distribute a to all terms. Here, FOIL. Then you can write negative x cubed plus 2x squared minus x plus 1 equals ax to the power of 4 plus 2ax squared plus a plus here bx squared times x squared gives you bx to the power of 4. Bx squared times 1 gives you bx squared. Cx times x squared gives you cx cubed. And cx times 1 gives you cx. Plus dx squared plus ex. This is too long. You have to focus to do not miss a term. Because if you miss a term or if you multiply in a wrong way, then all the answer will go wrong. Even when you start with calculus, your answer will be wrong, correct? Now you can write negative x cubed plus 2x squared minus x plus 1 equals, let's order a little bit. Here I have x to the power of 4. Here I have x to the power of 4. I will put them together. Even to reduce a little bit one step, I can factor x to the power of 4. I can write a plus b, and I can factor x to the power of 4. Correct? Plus, after power of 4, I'll put power of 3. I have c cubed here, and I don't have x cubed anymore. Then I'll put here cx cubed. After cube, I'll deal with x squared. I have 2ax squared here, I have bx squared here, and I have dx squared here. If I factor x squared, I'll end up with 2a plus b plus d and x squared common. Plus, after x squared, I'll put x. I have cx and I have ex. If I factor x, then it will be c plus e and x. And I have a constant term, which is a. Now, comparing the right side with the left side, you see x to the power of 4 is missing here. But based on the very basic algebra, I can add here 0x to the power of 4, correct? Now both sides are the same. Now I can make my equation. I can write a plus b equals 0, first term with first term. The second equation will be c equal negative 1. The third equation will be 2a plus b plus d equals 2. And the fourth equation will be c plus e equals negative 1. And the fifth equation, a equals 1. At least I have the value of c and I have the value of a. Then it's really, really easy to confine the value of b, the value of e, and the value of d. You see, if I plug a in this equation, which I have a plus b equals 0, if I plug in the value of a here, I will have 1 plus b equals 0. That means b equals negative 1. Now, if I use the value of C and plug in here, which I have C plus E equals -1, easily I can find the value of E, right? Then I can write -1 plus E equals -1. If I add 1 to both sides, then E is equal 0. This is the value of E. And finally, value of D. Plug A and B in this equation, and you can find the value of D. You have 2A plus B plus D equals 2. That means 2 times 1 plus B, which is -1. Even I can write -1. It's not basic algebra to put plus minus, right? You know, -1 plus D equal 2. 2 times 1, 2. 2 minus 1 is 1. 1 plus D equals 2. It means D equals what? 1. Now I have the value of A, B, C, D, and E. What was my fractions on the right side? I had A over X plus BX plus C over X squared plus 1 plus DX plus E over X squared plus 1 all squared. Plug in the value of A, B, C, D, E here, you will end up with A. How much was your A? Your A was 1. You can write 1 over X plus BX. How much is B? -1. Even you can change now the sign from plus to minus, right? Minus X plus C. How much is C? Your C is -1. It means X minus 1 over X squared plus 1 plus DX. How much is D? D is 1. It means plus X plus E. E is 0. X plus 0. Let me write. Even we can write it as an X, right? Over X squared plus 1 all squared. Now I'll set up my integral, and easily I can deal with integral, and I can find the value of the given problem, or I can evaluate my integral. What was the original problem? Integral of 1 minus x plus 2x squared minus x cubed over x times x squared plus 1 all squared dx. This one equals this integral, this partial fraction, integral of 1 over x minus 1 over x squared plus 1 plus x over x squared plus 1 all squared dx. Now separate the integral on the right side. You can rewrite this one as an integral of 1 over x minus, here you see I used the same method in previous problem. I can separate this one as a 2 fractions. I can write minus integral of x over x squared plus 1. Here, of course, dx, here dx, minus integral of 1 over x squared plus 1 dx plus integral of x over x squared plus 1 all to the power of 2 dx. I will write the answer here, assuming that you know that here you will use substitution, here you will use the trigonometric, and here you know how to deal with this integral because you have a square here. Your answer will be ln absolute value of x for the first time, first part, minus 1/2 ln absolute value of x squared plus 1 minus tan inverse of x minus 1/2 or 1/2 square x squared plus 1 plus c. That will be your final answer. I didn't do this part again. You can use substitution. Here you can use trigonometric, and here you know how to deal with this, correct? And this one will be your answer for the case, for this example, correct? These problems are a little bit long, but if you are good enough in chapter 6 and 7.1 to 7.3, I'm sure you will see it that it gets easier and easier and easier. It's not that difficult if you have enough practice with the rest of chapter 6 and chapter 7.1 to 7.3. This was all about chapter 7.4. You don't have anything else in 7.4 to cover. I'll stop the lecture here for you. And from here, we will jump to 7.8. As I told you, 7.5 is a kind of review. 7.6, you have to use calculator for 7.6, which we are not using calculator in our class. 7.7 is a technique of finding integrals, or the area of some functions that you can not use the formulas or the techniques of integrals to find those. Maybe at the end of the semester, I'll put a lecture for you for that. There are 2 rules. You are just following a formula. The main lecture will be again 7.8, which I will cover it in my next video for you. See you next time in 7.8.